In practice problem 4.2, I've got an airplane wing, and I need to calculate the total moment about the wing root that's due to these distributed forces. Now, an airplane wing is not uniformly loaded when it's flying. It has a different shape as you go from the wing root out to the wing tip. So the lift characteristics change and the forces change on the wing. But the total force is exerted on the wing root, and there's also a moment on the wing root. So let's begin. First of all, let's look at a free body diagram of the wing root, and I've got a wing. It's a badly drawn wing, and I've got this distributed load that looks like this, and I'm going to break this distributed load up into 3 distinct areas. I've done this in one of the previous problems. So if I look at just the wing, I've got a force due to, I'm going to make a rectangular section, and then I'm going to make a triangular section and another triangular section. And this is 350 pounds per foot. Again, this is 350 pounds per foot out at the end. I hate drawing these, by the way. And this distance is 950 minus 350. That's 550 pounds per foot. And the length along the wing is 15 feet and 13 feet. Now, opposing these forces, I have 2 other forces. A total net force pushing downward that the wing has the weight of the plane and everything else. And in addition to that, these moments all go this way. So there's an opposing moment going that way. And the question is, what is that moment? Okay, first of all, let's find the forces. I will call this area 1, this area 2, and this area 3. So area 1, also known as force 1, is 15 feet times 350 pounds per foot. Now this is not a moment. This is an area of a rectangle, and 15 times 350 is 5250 pounds, and because it's a rectangle, it's located halfway along the length of that rectangle. So x1 is 15 divided by 2, or 7.5 feet. F2, which is the area of this triangle, is the area of a triangle, which is 1/2 base times height. Base is 15 feet times 550 pounds per foot, or 4125 pounds. And Fx2 is located at 1/3 the length of the triangle, right there. So it's 15 divided by 3, or 5 feet. And then finally the third force, 13 feet long, 350. And its force is 1/2 base of 13 feet times 350 pounds per foot is 2275 pounds. Its location is 1/3 of 13 plus the 15. That distance always has to be from the same position. So x3 is 15 feet plus 13 over 3, 1/3 of the way from the big end of the triangle, or 19.333 feet. It's a repeating decimal. Okay. So what does this problem look like now? We haven't finished yet. Let's go to a new page. My wing now looks like this. Five feet from the end, I have a force of 4125. 7.5 feet from the end, I have a force of 5250. And 19.5 feet from the end, or 19.33 feet from the end, I have a force of 2275. The moment arms, which I just mentioned, 5 feet, 7.5 feet, and 19.333 feet. Now I can total up those moments. 5 times 4125 plus 7.5 times 5250 plus 19.333 times 2275. Notice that each one of those is going counterclockwise. And those are opposed by my M, my total moment. Punch these into a calculator. Add them all up. 103. 983 pound-feet. And that is our final answer.